Okay, here we go. All right. Well, I'll get to that in a minute, though, I guess. Let's see, where was I? Um, okay, I mentioned the constancy of the velocity of light, which is also called invariance or isotropy, or the like the velocity of light is isotropic, which means constant, which means invariant, and that means that I know I've described this a million times, but this just to familiarize us with the sort of new words, you know, like say there's a light source and you're stationary, like you measure the light source, you measure the light wave, and it turns out 186,282 miles per second, which is the standard value. It's the it's that's how fast light travels. However, though, if the observer travels away or towards how whatever the motions that for some reason it clocks out at the same value, the same standard, 186,282 miles per second. You think that add or subtract. That's the way we look. When you throw an object from a truck, in the direction of its motion, that's moving, at say 50 miles an hour. Yeah. Say you throw it 20, that's like 70 miles an hour. Yeah. When you add them up relative to the Earth. So it doesn't work that way with light, and that's a quandary that people are still puzzled about in many ways. There's supposed proof for it. I used to doubt it was true at all. I used to think there wasn't proof. They offered proof with Michelson and Morley did an experiment in 1880 or so, right, somewhere around there, to determine the motion of the Earth through the ether, which is the invisible substance that they thought permeated all of space, and that they thought that light might propagate only relative to that in a fixed way, and that they had this device where there were two light beams and one half silvered mirror, that one light beam could go straight, or it might have just been one beam that was split, and they went in different directions and they ended up in a sensor, and they wanted to determine, if light traveled at a different velocity in one of those directions, they might determine, well, the ether is at such and such place relative to our motion through it. They somehow wanted to find the Earth. They knew the Earth revolved around the sun. I've read they wanted trying to find the sun's position relative to the ether. However, the sun travels too. This was way before the Big Bang Theory experiment, the Big Bang Theory, where galaxies rush away. So he didn't consider that if there is a hypothetical ether that permeates all of existence, that all of these objects would be rushing through at high velocity, so you wouldn't be anywhere near the same place of space. But you can't really define it like in real terms. What space, like a given area of space, it's just an empty void. Things exist in space, and they exist and travel relative to each other. Yeah. But let me think. Where was I? Where was I? Oh yeah, about the ether. And I got sort of off track trying to explain the Michelson and Morley experiment. They came up empty and they couldn't detect the ether at all. So they concluded that the velocity of light is constant, which means that however fast you go through it, it clocks out the same every time. The velocity of light, c. So that prevails to this day in the mainstream as far as the established view. So a lot of people think the ether still exists, and but anyway, though, that was proposed as the only evidence of the ether, of the invariance of C, or the constancy of C, for quite some time. And I'd asked questions to Google so many times. What proof is there? They always said the Michelson and Morley experiment that proved the constancy of the velocity of light, which, for one thing, I don't think that it did. Given because the light beams are relative to each other and they travel relative to each other. The light beam from in the interferometer, which they called it. Y'all awake? Y'all have y'all's eyes closed. Y'all bored?
Oh no.
Okay. Well, what are y'all thinking of me? Y'all think I'm really weird? What do y'all think of me? Because sometimes I don't even know. I mean, I feel weird.
Well,
I don't know. I guess that's a weird question.
well, I know you're making sense to yourself. There's a lot you knowledge you have, and I think you're doing a decent job at
Oh, thank you.
portraying it.
Oh, thanks so much.
Mm-hmm.
I mean, I just know most people aren't obsessed with science and everything, and just lots of knowledge. But anyway, uh, well, well, hold on. Let's see. Where was I? Well, what was I saying? Oh yeah. Okay. This, if this is true, this seems to prove the constancy of the velocity of light. You know, like for instance, there's no way you could set up in reality, you know, a light source and an observer. You know, one of them traveling near the velocity of light to see if it stays the same. I mean, there's no way to set that up in real life. However, in lab experiments, I only recently found out this. And I'm surprised I never stumbled across it before because I'd asked many times on the internet. But what it said was they could accelerate charged particles that glow. These charged particles glow.
Yeah.
And when they accelerate them really fast, and say they go to constant velocity or whether they even keep accelerating, the light received from the sensor at the other side registers them at 186,282 miles per second, the standard value.
Yeah.
So, you know, it would seem that if it weren't true, that the light would seem more because the light's traveling with, you know, the particles are glowing.
Yeah.
It would seem the particles' velocity and the velocity of light if the constancy of the velocity of light weren't true.
Yeah.
You know, so that seems to prove it. However, though, I'm still skeptical. There was other alleged evidence that turned out that it was fabricated. With the famous clock on the plate experiments. The first one was admittedly, well, he didn't admit it. He sent in the actual figures. He submitted the actual figures, which weren't conclusive at all. But he secretly switched them. Like he sent them into some high up headquarters, so, like some sort of official place.
Yeah.
And some like someone who wrote a paper on this, like just simply requested those original papers, which he got them. But as it turns out, Heifel and Keating had secretly added in they did all these calculations to find out what they thought would be the predicted result. So whenever they you know they knew they couldn't present their findings to the public because, well, that doesn't prove anything. So they went to all that trouble, you know, flying these clocks on the plane, having them in controlled conditions, like, you know, just everything involved with the highly precise atomic clocks, you know, that since their results weren't conclusive, they faked them, and they added in what they thought they should have gotten. And so they say, well, yes, it was predicted by Einstein's relativity that these correct estimations would be accurate, even though they fabricated it.
Yeah.
And so I only recently found this out. So I even consulted ChatGPT about, you know, what if the hypothetical I heard they were possibly fabricated. And so it said, well, if this experiment was indeed fake, they said, well, there's been many experiments since then that have confirmed it with clocks on planes. Yeah. So, you know, how to trust so many things. Yeah. Like Rupert Sheldrake did a video where he spoke of he went to the patent office because he wanted to find out if the velocity of light stayed the same throughout the years, like the accepted value.
Yeah.
So he went through all these patent books, like these old physics textbooks. He said he went there because he couldn't find them anywhere else because, you know, like year by year, the textbooks they'll discard the old ones because when the new values change, they'll have new textbooks. Not necessarily because of that, but they just discard the old ones. And so he found all these like through 1945 to 1928 to 1945, I think it was. There was a discrepancy. The velocity of light lowered. I mean, it didn't just stay one amount. It just fluctuated. So he went to the head of metrology, like in London. Well, I don't know if it was London. He might have went somewhere else. But and asked them, you know, what do you make of this? Of why the velocity of light had lowered? You know, it was a significant drop. So why was that? And the head of metrology said, "Oh dear, like metrology is the study of constants. Which is like the velocity of light is a constant. It's always the same. Gravity constant, and there are other constants that I can't remember. Anyway, though, so he asked the head of metrology, what to make of this drop in the value of C in those textbooks, and he said, "Oh dear, you've uncovered the most embarrassing episode in the history of our science."
Oh no.
He went on to say, that well, see, Rupert Sheldrake was asking, well, how did they arrive at these figures? Were scientists in different labs doing the experiments, coming up with different results, and just averaging, they would average them out. When they got different results, scientists would average them out.
Yeah.
That doesn't sound very scientific to me.
Doesn't.
Yeah. And so he asked them, were they sort of fudging the results, to get the same result they thought everyone else would be getting? And the head of metrology said, well, we don't like to use that term, fudging. We prefer intellectual phase locking.
Okay.
And so he made it sound more official, like, oh, well, that sounds excusable then.
Yeah.
Yeah. But anyway, though.
Are you recording that?
Yeah, yeah. Yep. Let me think. Anyway, so he found that discrepancy. So Roper went on to say, well, how do we know we still aren't getting the different values to this day? And and how do know we have the correct value? And he said, well, we solved that problem. We fixed in 1972. We fixed the meter by definition because the meter is based upon the velocity of light.
Okay.
The velocity of light is, well, there's a slight discrepancy. It isn't exactly 300 million meters per second. It's like 299 something, like it's very, very nearby.
Yeah.
But so where was I? Anyway, yeah. Okay, they fixed the meter by definition. So it's they aren't going to alter the meter, but the velocity of light is based. The meter is based on the velocity of light. They used to base it on the distance between the equator and the North Pole, like just divided down. Like say,
Yeah.
I forget what the figure was. It was a different figure than light was. It was something like, I mean, I can't even begin to guess, but it was like a certain number, a rounded off number that like if you divide it out, it's like this small fraction of that.
Yeah.
So the velocity of light is a 1, like a fraction. It's like a 1 over 300 million meters per second. Like just one of those. That's a meter. Isn't that interesting, though?
It is.
Anyway, though, once they fixed the meter by definition, they weren't they aren't going to change their minds. And I mean, even if they keep experimenting and found the velocity of light is different, who's going to say so and disrupt the meter? Or I mean, not saying that's the only reason why, but it's become like an intellectual phase locking, as the guy mentioned earlier, that they fixed the meter by definition, that they don't want to question the established value. I mean, if they suddenly say, "Oh, well, we've been wrong all this," they put so much emphasis and authority into saying, "Well, yes, we've done these controlled experiments, and we accelerated these charged particles to just 0.001% away from the velocity of light." But if they suddenly said, "Yeah, we had the velocity of light itself wrong," I mean, that would make them seem like they were bragging about their superior knowledge when they really were just, exaggerating, and they weren't really telling the whole truth,
Mm-hmm.
So I mean, that sort of thing, like how to know, like Rupert was asking, how to know they aren't getting different values of the velocity of light, how to know we have the correct value. So, as far as the accepted value of the velocity of light, I mean, how to know they aren't getting different experimental results, but just that no one wants to step up and want the controversy to even say, hey, we need to change all of these textbooks, and I mean, it would seem huge, and it's sort of sad because like the tradition of I mean, traditions like, let me read what I wrote like later on that I mentioned.
Sure.
Okay, Mom, you interested in this?
Mm-hmm.
Okay. You sleeping, huh?
No, I'm listening.
All right. Okay. Okay. I'm not going to say this. I might say this for a later presentation. Or I might write this through an email. And I don't know if it's sort of maybe even too over the top or something. Okay, here it goes. I often realize my ignorance as I learn more, even when I thought I was completely certain of something. This has been an ongoing theme throughout my 3 decades of independent studies. I'm sure countless other scientists have experienced this as well. As physicists, as well as other professions, we have that common interest, so we often correspond, whether it's to teach, learn, or just compare ideas. Of course, we find agreement and often disagreement. Of course, I disagree with certain mainstream ideas such as relativity and the Big Bang. However, I think Neil deGrasse Tyson, Bill Nye the Science Guy, and quite a few others often fascinate their viewers as they have a brilliance at explaining complex ideas to experience as well as those inexperienced in science. What if we were to consider them more of allies who just happen to disagree on certain points? Um, One possible way to persuade other scientists is to have an openness to the possibilities. What if we didn't completely dismiss the mainstream? What if we were to simply present ourselves as people with honest questions regarding physical phenomena? We've arrived at them through reason and observations, which is the main priority of science. The complete and complex field of science is incredibly vast, and through such knowledge and practical application, it has transformed the world tremendously. Through invention, medicine, construction, electrical technology, and much more. What is common practice in our day wasn't even thought possible by people who lived a century ago. It is this extraordinary capacity of ours to think, learn, and understand, and creatively apply this knowledge which has transformed the world. Historically speaking, this type of interaction through online forums through the use of such technology is a very new experience. Through the past millennia, research was just that, a driven, interested, yet tedious search of main ways that a few of the main ways was previously through books, often at libraries. Also, gatherings to discuss knowledge was often planned at various places to give and listen to speeches or to speak to others individually or in small groups. These weren't seen These were the common ways to learn and educate people for the past few centuries, given that much before then, schools and libraries weren't seen as important, so they weren't readily available. We live in this unique and unprecedented time with this amazing medium which we could use to share ideas and enlighten ourselves. I'm happy to experience this potentially important point in history to ask questions, inspire thought, and to help share valuable ideas and knowledge. We're very lucky today to have, okay, these are sort of separate things that, like, I kind of spliced certain things I wrote together. I just took things I'd written before. Some of this I'd written before, but just added to a lot of it I just wrote just yesterday or earlier today even. So anyway, you know,
Okay, go ahead.
all right. We're very lucky today with our modern technology to help us create more progress in the world. We had the opportunity with our current technological setup to convey some of the most valuable knowledge we've gained in the pursuit of truth, understanding, and wisdom. Of course, most of us, as dissidents or critical and open-minded thinkers, tend to have beliefs or ideas that differ, at least to some other individuals who also consider and arrive at views that aren't popular or within the mainstream. A lot of this is very wordy and just boring, even some of it. The main different views of a variety of an idea, topic, or theory shows that we actively think and consider the idea and strive for meaning and accuracy. We could present our process and approach. We could present our process and approach and some of our findings, and also to each other and anyone else who is interested. It shouldn't seem that we all have to always agree to find ways to advance scientific knowledge. There's quite a variety of unanswered questions and inevitably continue to exist. It seems reasonable to expect this. though to find and understand some valid scientific truths also seem possible. David Hilster. David once asked the question how to present alternate ideas to the public or the scientifically inexperienced. He also asked how we could seem most persuasive. We, this just real my eyes. We can invite, or this I wrote at a different time. We can invite all interested individuals to listen, consider, and arrive at their own conclusions of whether reviews regarding relativity and various other ideas seem accurate, where all the available evidence, pro and con, is brought to the table to objectively consider. Of course, we all once didn't know what we learned throughout our lives. We all had the capacity to reason, yet those of us who haven't yet had the chance or even interest to study some of the established ideas within various scientific fields may initially feel somewhat overwhelmed by many of the ideas which seem so complex, some which don't seem logically sound or understandable. The technical terminology may seem somewhat imposing and cause genuinely interested individuals to feel discouraged, which may prevent them from inquiring further. Maybe we could provide a place where they have the opportunity to hear and consider ideas expressed by a variety of scientists whose dissenting views have been the result of years and even many decades of the pursuit of truth. All individuals, even including those with a high degree of specialized knowledge and understanding, literally started out without knowing anything. It takes time to steadily gain knowledge. We learn through the thoughts of others, and we also arrive at our own thoughts, knowledge, beliefs, and approach. Of course, we couldn't expect everyone to immediately understand or have familiarity with the ideas we've learned. This is especially so when the ideas get very complex. Of course, much of it seems so everyday to us that we forget that we specialize in highly technical knowledge and theory. Of course, most people haven't had the time or interest to research a given area of knowledge. If the mainstream and those with alternate views didn't seem so separated, the more potential would exist for ideas outside of the mainstream to get considered. If we consider ourselves in sort of the same position as all scientists, traveling on similar intellectual journeys, we could more readily relate and establish a social connection with. Of course, we couldn't have a conversation with deceased scientists to let them know of factors of which we weren't aware in their day. It seems that we often rely on the past for our current and future choices. Of course, tradition is a common and inevitable reaction to the human condition. It is often positive and admirable, though sometimes it's a way of seeing things that doesn't serve a good purpose. The fact that it is established suggests that it was or is popularly accepted. However, throughout the ages, it has been times when the status quo was questioned and a new way of seeing things was realized that progress happened. Of course, the chance is always there for us to take a fresh new perspective and approach the future as a vision to achieve. Okay, that's all I have of that. Yeah, that's all I have of that. Anyway. There was something well, no, I guess I did read everything. I guess that's all. I guess, I think I went over the main points.
Good. Enjoyed it.
Oh, thank you.